We've been observing this object for weeks. Its behavior was unusual, but at least it followed a pattern. Then, something shifted, a sudden surge of activity, and right after, NASA went silent. Updates stopped. Briefings disappeared. Questions were redirected. Silence like that rarely means nothing. It usually means the explanation is bigger than they're prepared to give. And once you see what happened in that moment, you'll understand why this story is only just beginning. When this object first appeared in the public tracking catalogs, it didn't spark any major headlines. It was logged, classified, and placed in the same routine monitoring cycles that thousands of other objects pass through. To most observatories, it was just another entry in the ongoing stream of celestial traffic. A distant traveler, interesting enough to record, but not special enough to demand attention. Teams around the world observed it in passing. Telescopes in Hawaii, Spain, Chile, and Australia all collected data as it moved along its projected path. The numbers lined up, at least at first. Its speed, its brightness curve, everything fit within the expected parameters for an interstellar visitor. It was notable, sure, but not alarming. Something to keep an eye on, not something to interrupt schedules over. But there were small, quiet inconsistencies right from the beginning. A slight deviation in trajectory that corrected itself too smoothly. A brightness shift that appeared and then settled again without any external trigger. These weren't dramatic enough to draw conclusions from. And in astronomy, anomalies that can't be explained quickly are often just filed away under instrument noise or calibration variance. Scientists are trained to avoid jumping to extraordinary explanations without extraordinary evidence. So those early irregularities were mentioned, documented, and then essentially dismissed. There were a few researchers who hesitated. They noted how the object didn't behave exactly like others we've tracked before. They wrote short internal memos, small observational notes, questions without answers. But none of it was enough to make anyone change course. After all, the universe is full of exceptions, and most of them lead nowhere. So the object kept moving, data kept flowing, and the story remained quiet, almost background noise, as it continued its journey deeper into our system. Everything was manageable until the activation. The change didn't announce itself. It hit all at once, sharp, immediate, undeniable. One night, the object's brightness held steady exactly where everyone expected it to be, and then without warning, it surged. Not a gradual rise, not a slow response to solar exposure, just a sudden, measurable leap in luminosity that didn't belong there. Astronomers who were watching in real time thought it was an equipment glitch. Some recalibrated their instruments, restarted their tracking software, ran diagnostics, but when the same spike appeared across independent systems from different locations and different setups, the conclusion became unavoidable. The object itself had changed. Then came the pulsing. The brightness didn't simply increase and stabilize. It began to repeat, bright, dim, bright, dim, at consistent, evenly spaced intervals, not random flickering, not turbulence, a rhythm, a pattern, something holding timing the way a signal does. And layered inside that shift was the return of the 637 nm emission, the one that had appeared fleetingly before, only to fade before anyone could define it. This time it held, strong, persistent, clear enough that even cautious researchers stopped wording their notes lightly. You don't see something appear at a wavelength unaccounted for by known materials and shrug it away. You document it, you question it, you double-check the question itself. No one publicly used the word intentional, not then, but the internal tone changed. Private discussions became sharper.
Data review sessions went longer. Researchers who had once dismissed early irregularities as coincidence began requesting access to raw spectral files. Something about this didn't feel like noise anymore. It felt coordinated. Not explained, not understood, just coordinated. And while the activation itself was startling, What mattered most wasn't what happened, but when it happened. But the timing of that activation is what changed the conversation. The real issue wasn't the activation itself, it was where it happened. If this were a natural reaction, the surge should have occurred much earlier, when the object was closest to the sun, where heat and radiation are strongest. That's when typical bodies show their most dramatic changes. But that's not when this shift took place. It happened near Earth. Not dangerously close, not in a way that implied immediate threat, but close enough that the timing forced a different kind of question. Why now? Why here? That's what fractured the scientific community. The first group tried to maintain caution. They proposed delayed thermal effects, unusual internal composition, slow-release subsurface activity, explanations that didn't require rewriting established models. Their approach wasn't denial, it was discipline. You don't abandon known physics because something is confusing. The second group didn't reject caution, but they recognized a pattern in the response. They noticed how quickly discussions began shifting behind closed doors, how private calls replaced public statements, how researchers who were confident and vocal days earlier suddenly chose their words more carefully, not because they had answers, but because they didn't. Internal debates grew sharper. Memos became more guarded. Small observations that were once casually shared in open channels moved into restricted access threads. And when professional conversations migrate from collaborative to careful, the tone is telling. The question was no longer simply what happened, but what the implications would be if the most direct interpretation turned out to be correct. Then the public silence began. Updates stopped without explanation. Press briefings were postponed. Requests for routine commentary were redirected to generic statements. No clarification, just absence. And silence like that rarely means someone has the situation under control. Silence, however, only fueled the next discovery. Once it became clear that the object's behavior didn't fit the usual patterns, the discussion shifted. It was no longer just researchers comparing observations. The moment the structured radioactivity entered internal reports, the situation moved from purely scientific review to something handled much more carefully. Not because anyone understood the meaning, but because of how the information might be interpreted publicly. NASA's communication style changed first. Updates that had been detailed became brief. Technical notes that were once openly accessible were moved into restricted access internal channels. Observatories that usually shared raw data in real time now circulated summaries instead. Nothing was explicitly hidden, but the flow of information became narrower, slower, and more supervised. Meanwhile, China continued releasing observations through academic networks and agency bulletins. Their tone wasn't provocative or speculative, just transparent. They shared timestamps, frequency logs, and instrument notes without waiting for international consensus. The effect was subtle but noticeable. Researchers outside the US found it easier to follow China's data than NASA's. This created a practical shift. Collaborative projects that would normally involve international teams began to stall. Draft papers were put on hold pending review. Group mailing lists that once held open discussion became noticeably quiet. Researchers who had spoken freely just weeks before started using cautious language, sometimes avoiding conclusions entirely. No one issued a directive. There was no formal policy change, but the environment changed. Access, timing, and tone were now part of the process. The question scientists were quietly navigating wasn't just what does the data show, but when is it acceptable to discuss what it might mean? The science remained the same. The behavior of the object remained the same, but the response to it had become something entirely different. And this leads to the part nobody wants to talk about. As more data accumulated, attention shifted to something subtle but measurable. The object was no longer following the exact path projected during its approach. When researchers compared the inbound trajectory with the outbound path, the two no longer aligned precisely. The difference wasn't large, it was the kind of variation that, under other circumstances, might have passed without comment. But it persisted. Over multiple observation windows, the outbound trajectory continued to diverge in a consistent direction. Not erratic, not fluctuating, just steadily offset from the predicted curve by a margin that increased slowly over time. The effect was small, but unmistakable to teams who monitor orbital paths for a living. Natural explanations were reviewed responsibly and in order. Known forces were modeled, standard adjustment factors were applied. The expected outcomes didn't fully reconcile with what was being observed. The question was no longer whether the trajectory had shifted, but what the most reasonable interpretation of that shift should be. That's when the tone of discussion began to change. Not publicly, not in published work, but in internal calls, research memos, and informal conversations between colleagues who have tracked similar objects for decades, the phrase possible course adjustment began to appear, carefully, tentatively, framed as something that required continued verification. No one was prepared to assert intent, no one claimed a definitive cause, but the implication was clear enough. The change in trajectory behaved less like drift and more like guidance. This didn't lead to a unified conclusion, it led to quiet consideration, a widening of the theoretical scope, a recognition that the simplest explanations were no longer sufficient on their own. No announcements were made, no statements were revised, but priorities shifted. More instruments were pointed, more resources were allocated. The object was no longer just being observed, it was being monitored. And that's when the timeline for answers began to shorten. But confirmation may arrive much sooner than expected. The approaching Close Encounter mission wasn't launched in response to any of the recent activity. It was planned long before the object's behavior changed, part of a broader initiative to study interstellar bodies as they pass through the inner solar system. At the time, it was viewed as an opportunity to gather useful data and refine models. Important, yes, but routine in scope. Now, its role has shifted. The spacecraft is on a course that will bring it into controlled proximity with the object. Not close enough for contact, but close enough to obtain detailed imaging and direct measurements that cannot be captured from Earth-based observatories. The instruments on board are designed to analyze surface texture, temperature gradients, and compositional signatures with far greater clarity than spectral readings taken from a distance. For many researchers, the goal is clarity more than discovery. Surface geometry can reveal whether an object formed through natural processes or through something more structured. Thermal distribution can show whether heat is radiating evenly or from localized sources. Even the simplest patterns, regular striations, repeated angular formations, abrupt boundary transitions, could guide interpretation in ways that current data cannot. No one is predicting what the spacecraft will find. The conversations happening now are measured, careful, and conditional. The focus is on what becomes possible when observation shifts from inference to direct imaging. If the return data resembles other known interstellar bodies, the discussion stabilizes.
If it contains meaningful irregularities, the discussion moves into a different phase, one that requires new frameworks and more deliberate coordination. Everything depends on what the cameras and detectors record during approach. The timeline is set. The trajectory is steady. The moment of clarity is coming. Which leads to the question that now shapes every discussion. What happens if the answer changes what we thought was possible? Right now, we're in a waiting phase. The data we have raises questions, but the answers are still ahead of us. The object's behavior has shifted, communication has tightened, and the upcoming Close Approach mission is the turning point. That's when interpretation becomes observation, when speculation becomes verification, and when silence will no longer hold. Until then, we're watching something rare, a moment where our understanding could change, where the familiar framework of how we view objects moving through our system might need to be updated. Scientists are preparing for multiple possible outcomes, not because they expect something extraordinary, but because the range of explanations is wider than usual. Even the most conservative researchers are acknowledging that this encounter holds more weight than routine observation. Nothing has been confirmed, but the possibility alone has shifted focus and resources. What matters now is patience and precision. Data will speak when it arrives. If the imagery resembles known interstellar bodies, the conversation stabilizes. If it doesn't, then we move into new territory. Either way, the next stage begins soon. So for now, here's the question that matters. If something out there is observing us, how do you think humanity should respond? Tell me in the comments. I want to know what you think. There isn't a right or wrong answer yet, and that's what makes this moment important. And if you want to follow this story as it develops, when the new data drops, when the images are released, when the interpretation shifts, make sure you're here for it. Subscribe so you don't miss what comes next. Turn on notifications because the updates may arrive suddenly. And if this helped you understand the situation more clearly, leave a like. It really helps more people find this information. We're heading into the most revealing phase of this entire investigation. I'll see you in the next video.